All right, Nikki, are we live on stage right now? Okay, we're good to go. Perfect.
Yep.
All right, so I'm going to start recording. James, this is going to go live on YouTube, just so you know. Perfect. All right. Well, welcome everybody. I'm going to go ahead and share my screen, and then I can introduce James Ashton, our speaker from Georgia. Let me know if you guys can see my screen. 1 second, please. Can you guys see my screen?
Yep.
Awesome. Well, welcome everybody. My name is Monica Rojas. I am the Membership and Inclusion Specialist at Tech Hub South Florida. And today we have a special guest, James Ashton, VP Network Operations at 365 Data Centers, joining us from Georgia. And we'll be talking on digital infrastructure integrations. All right, so a special thank you to our sponsor for tonight, Kerry Stamp & Co. Kerry and his team have been sponsoring our Tech Talks for the last month or two, and they're amazing finance company, personal wealth management in West Palm Beach and Palm Beach Gardens area. Yes, so for those of you guys who don't know about us, we are Tech Hub South Florida, and our ultimate mission is to build South Florida into a tech hub. And we do so by hosting certain events like this, by connecting our community, and providing and retaining talent down here in South Florida. So this is our community creed. We're wholeheartedly committed to building a welcoming, collaborative, and inclusive community for all. We're definitely a people first organization, and we really encourage that we don't sell to each other and collaborate first. Yes, so we are a nonprofit, and we have about 200 corporate members. So we have our partners at the bottom, if you'd like to take a look, 1909, FEU Tech Runway, and a few others throughout South Florida. So as you guys know, we recently expanded, and we have partners all over South Florida, including Broward, Miami, and that includes with our memberships as well. And these are just a few of our current members. So we have Office Depot, Boca Code, Digital Resource, DSS, Social Mobile. A special shout out to all our big members for making our tech hub the way it is today. And these are just a few of our membership benefits. So we do have weekly newsletters. We have job listings and resume distributions. And you can actually go on our career board on our website if you're looking for a job. We do member spotlights and guest blogs. And we also have inclusive peer groups for different types of leaders in our community, as well as speaking opportunities like this one. And I also mentioned to James that we will be doing one in person, hopefully soon. And James is going to have to join us once he's back in Boca Raton.
Sounds like a plan.
All right, so this is just our weekly event schedule. So every Monday night we do Tech Talks at 5:30, networking 5:30, and then the presentation starts at 6. We have community coffees on Tuesday mornings. Actually, it's every other Tuesday. And we also have podcasts that have to be updated as well. So one Tuesday we'll do community coffees, the other Tuesday we'll do podcasts. And on Fridays we do lunch and learns called Food for Thought. So we usually change that topic based on whether it's startup, personal development, or if we're going to do some tech development as well. Yeah, so this is a resume distributor. So if you guys have a moment and you guys are looking for a job, feel free to visit Tech Hub South Florida under careers and resume distributor, and you can submit your resume and it'll be sent out to our list of employers, also our members here in South Florida. Yes, so if you haven't done so already, please feel free to join our Slack channel at southfloриdatech.com/Slack, or you could just text this number and you will be added to the list. All right, so that is all I have for now. I'm going to hand over the mic to James. Thank you again, James, for joining us, and then you can go ahead and share your screen whenever you're ready.
Okay, well, thank you much. Let's see here how this here thingy works. Okay, share. That seems like it worked. Everybody see what I'm, there we go. Perfect. Even I can see what I'm sharing. That's interesting. That's new.
And Monica, do you want to remove me from the stage so people don't see my mug up here the whole time?
Yeah, sure.
Okay.
Okay, well, everybody, welcome, and I guess thank you for coming to hear my little spiel, and hopefully we can have an interesting discussion afterwards. Um, so, 365 Data Centers is an infrastructure company, and I'm the VP of Network Operations, which basically means from a network infrastructure standpoint, that's me. That's my world. We do a lot of working together with other types of infrastructure and other companies, and that's kind of what I want to talk about is what the infrastructure of various environments that we build or that customers need looks like, and how different pieces of technology integrate. Um, I'm going to start talking about the building blocks of infrastructure, or what I'm talking about when I'm talking about infrastructure. Uh, what combining those building blocks actually means or looks like, some basic examples, some more complex examples, some of the newer technologies that people have been integrating in the last couple of years, which honestly, from an infrastructure standpoint, isn't always as forward seeming as you would think. But it is very interesting to work with, particularly at scale. And then, maybe talk about some of the newer stuff that's coming out. And then, I think we can maybe have a discussion about that and see if it's interesting to everybody. So the basic building blocks of infrastructure from my standpoint, of course, as I said, I am a network guy at heart. So I start off with the network. So network infrastructure, pretty much from a carrier point of view, represents routers, switches, firewalls, long haul fiber, dense wave division multiplexing to make better use of that fiber, amplification of light, that sort of stuff from a hardware standpoint. But from an actual services standpoint, I think that what we're mostly building with is internet access, or DIA, dedicated internet access. There are many names in the industry for that, but basically, basic internet access, giving you access to all of the other facilities and users out there on the internet, and giving people access to your content. An E-line service, and this is a MEF, Metro Ethernet Forum term, but it basically means a point-to-point layer 2 service. So essentially, think of it as stretching a virtual wire, or a pseudo wire, as Cisco likes to call it, between one location and another, to make those locations appear as one from a network standpoint. So just like running a wire across your home to connect one computer to another, or one computer to another part of your network, the same goes for business. You can build a layer 2 service from anywhere to anywhere else to allow two different components to speak. An ELAN service, which is a multi-point service, very similar to an E-line, only allowing you to connect multiple services or sites together. So, if you have 4 or 5 different offices at your company, an ELAN service allows all of those to talk together, and potentially to speak to a data center, or the cloud, or some other componentry you have somewhere that your employees need to access. So those are the basic building blocks of network infrastructure. From a cloud standpoint, infrastructure-wise, you have, of course, virtual servers. Various cloud offerings, and we were talking earlier about AWS or Azure, and other large cloud providers, or public cloud providers. There are a lot of cloud providers out there, small, medium, large. We offer a cloud service, so we're a medium-sized provider. There are, you have your AWSs or your Azures, which are large providers. There are also many smaller providers available out there that offer, 1 or 2 servers, or, they specialize in things like web hosting and web servers, etc. But, outside of standard virtual servers, you have appliances. And, again, network guy. In my world, virtual network appliances, or otherwise known as virtual network functions, or VNFs, are very common. So you have your basics, your virtual firewall, maybe your virtual web server or web appliance. But there are many others: virtual traffic generators, virtual traffic sniffers, virtual network optimization boxes, virtual load balancing, et cetera. I mean, there's basically an endless number of appliances that are out there, and that leads into storage and backup as well. With the advent of the cloud and how much is virtualized today, virtual storage and backup and offsite backup is just a huge product set. Data is increasing. Actually, what's very interesting is talking about data size. Data is being put to disk today faster than disks are being produced by manufacturers. So there's more data growth out there than there is storage growth. So storage becomes ever more important. Compression, ways to optimize it, ways to access it remotely so that you don't have to store your data in 5 or 6 different locations. Just ways to make all of that data accessible to everybody, whether it be you and your employees or your customer base or the general public. And then the basis of all of this is essentially the physical power and space and air conditioning infrastructure of the telecom community or data centers in general. So 365 data centers. We are a data center company. We have 13 data centers up and down the eastern U.S. There are lots of really great data center companies out there. Equinix, Digital Realty, CoreSite, et cetera. Many, but there are also a lot of smaller and regional data centers that do amazing jobs that oftentimes customize what your needs are. They'll build out some very, very specific space that meets exactly what you need for whatever you're doing. So from a digital infrastructure point of view, data center would be like space and power, physical servers, physical appliances, anything that you actually, order that ships to you, that you touch, that you have to rack, that you have to keep cool, that you have to plug power into. That would largely be the physical or the data center infrastructure there. So those are the basic building blocks of what we do. Combining services, this is very basic, very simple seeming, but at its heart, combining services is essentially whenever you're in a situation where you're buying one or more nearly a la carte services that you combine to do one thing or offer one service. The most basic would be if you have a server that you're renting or you're purchasing, or maybe it's a cloud or a virtual server, and you also get internet access with it, which is almost ubiquitous enough where people consider a server and internet to be the same thing, where actually they are, in most cases by the provider, considered separate services. But there are lots of other services you can combine or that are commonly combined. That just happens to be the most common or the most easily represented. Other common things is one service within another service. A lot of times, and this is very common once you start moving into more complex cloud environments, is where somebody will buy some virtual servers, maybe several, and they'll want to protect them, so they also buy either a physical or a virtual firewall, and that virtual firewall lives within that cloud or that virtual environment. So you're purchasing virtual resources for servers, but also maybe a managed or maybe managed by yourself firewall or security appliance somehow. Other examples, customers of ours anyway, that we've run into, a lot of customers will come into a data center and they'll buy rack space and power, and they'll want to bring in a lot of servers to have their own virtual environment present at the facility. that's great. That's a very common thing, and it's been happening pretty much since VMware showed up as a company on the market. And but what a lot of people don't do, a lot of people, they have one large virtual environment, but they're not really looking to have two or three. So if they need failover, or they need data backed up, or they need some reassurance that in the event of a major hardware failure, they're still going to be online, they'll also purchase replication into our cloud, or into AWS or Azure or Rackspace, or any one of the other cloud providers out there, Oracle. And they'll either want to replicate all of their virtual machines over there, so that in the event that their environment here goes down for whatever reason, they can come up there. And that's kind of what people think about when they think of cloud. You don't really think about a stack of servers in one location. You think about these virtual amorphous servers floating around in the clouds or in the ether somewhere. And if one goes down, or if you have a problem in one location, your server just kind of magically matriculates over to another location. And that's not actually something that happens on its own. That's a stack of separate services that come together to make something like that happen. And that would fall under basically a complex combination, where people have multiple appliances, maybe lots of servers, they have data replication from one site to the other. Maybe they have some complex routing that allows them to have equipment running at both locations simultaneously. Or in some cases, if you're at one site and that site fails for whatever reason, and you fail over to another site, that it takes your network services with you. And those are some complex services that can be built on the cloud, or can be built out of these different infrastructure options that are out there. So common basic combinations, lots of people have servers. Particularly, I noticed that we had quite a few people who dealt with software in the audience. And if you have a large software presence, or you're writing a lot of software, the software has to run on something. And most of the time nowadays, it's either on a container or on a cloud virtual server of some sort. And for that server to be useful, at the very least, it needs internet access. And that's, again, the most basic option that you can think of is, hey, we have a server, it has internet access, we can now access it, we can upload our content, whether that be a website or an application or just data. And we can make it accessible to everybody, and everybody can see our website. This is usually with a single server with just internet access. It's usually a Unix environment. Very seldom do you see Windows servers exposed directly to the internet. It does happen from time to time, but again, it's usually in this sort of environment, it's like a single Unix server or a couple with direct internet access, and maybe software firewalls running on them. The next would be, servers behind a firewall, and we spoke about that a minute ago. If you have a couple of servers or several servers, you can put a security device or a firewall in front of them, allowing you to filter access in and out to the server to only allow the applications or the connections that you want to and from the places that you want. You can do that with or without NAT, network address translation. Most of us have that running at home to allow you to have multiple servers or multiple desktops or whatever running in your house to connect through your single internet connection. You can do that in the data center as well, or in the cloud as well, but you don't have to. Usually, even with IPv4 addresses today, usually there's enough addresses so that everybody can put the servers that they need online with an IP address directly on the server. Physical or virtual firewalls are very common. A lot of people, if you have data center space and you have a physical presence, you'll have a physical firewall. If you're choosing to have to rent or lease virtual space, or maybe even if you have your own virtual environment, you'll choose to go with a virtual firewall. Surprisingly enough, virtual firewalls aren't always the most cost-effective way to go, but they're very, very flexible. It's very handy to be able to migrate them around. If you have a piece of hardware that fails, the virtual firewall can move on to another piece of hardware. So you don't really have the single point of failure that you would with a physical piece of hardware, necessitating you buy two of them so that you have some redundancy. So virtualization is pretty good that way, but usually the VMs do cost a little bit more than the lower end hardware appliances. And then E-lines or point-to-point services, as we mentioned in the previous slide, can allow you to connect from your office or multiple offices, or your home for that matter, into the data center or the cloud. It can also allow you to have cloud presence in multiple locations and connect the layer 2 or your LAN on those two presence together. So you could have Azure VMs, and you could have AWS VMs, and you can have Oracle or 365 data centers VMs, and they can all speak to each other, allowing you to be, in multiple places at once on multiple infrastructures and not tied to any one piece of hardware or company or corporate policy set. So that's kind of handy, and it offers a lot of flexibility. It's the building block of some of the more complex services that are out there. So from an explanation point of view, or from a discussion point of view, the complex things I'm kind of going to go into some diagrams on, because you start layering too many things and it becomes difficult to talk about without being able to visualize. So here we go. This is something that I built last year for a customer, and I actually tend to use this diagram a lot because I think it turned out pretty readable and understandable. But in this instance, the customer has 2 data centers and 2 large offices with call centers and actually separate internal companies. They have one company in this case that is doing importing of things, and another company that is the law firm that handles the legal issues. And they are actually both subsidiaries of the same company, but because of the legal needs, they had to physically separate the connectivity, but they wanted one IT infrastructure. So, at each of their offices, they have a firewall, and they have physically separate ports on the firewall going out to different parts of their office buildings. The law firm at one part of each of the buildings, and the business itself in another part. They both come back to the same firewall. The firewall then permits addresses from one company to access the network in one way, and IPs in the other company, or computers in the other company to access the network resources in another way. Both of those offices come back through some of our data centers, and then they connect to a complex network service. In this case, it's an L3 VPN, so it's a layer 3 private network. And that routes out to 2 different data centers where they have a large private cloud environment built custom for them. And they have one site that is primary, and it is live. It has all of their servers and all of their environment at it. And that is replicated to another site, and that site only comes online in the event that the primary site fails. So in this case, we have 2 private cloud environments. So that's, a hardware environment running lots of virtual servers. So, lots of VMs living on that, lots of services there, with virtual firewalls connected via a single multi-point network service to a couple of data centers. And then from those data centers, we have connections out to their offices, which are, again, additional network services, where we have managed firewalls at each of the offices. And those are additional network services, allowing us to separate for them, based on their policy, the different companies that are subsidiaries, and how they can access, which virtual machines they can access, which storage they can access, which file shares they can access. They actually use VDI, so they use virtual desktops and thin terminals at their offices, so they don't actually have full computers at the office, everything runs off from virtual machines back at the data center. And with the replication from one site to the other, that way, if there's any hardware failure, if the facility has any problem at the primary location, they can fail over to the secondary and stay online. Through testing, we've seen all of the virtual machines fail from one site to the other, and they're online in about 2.5 minutes because they all have to reboot simultaneously into the new location. But it's pretty quick, it's pretty reliable. It allows them redundancy in all of their network and all of their server and compute resources. There's no single point of failure. And it allows them to operate as a business, and they're pretty happy with that solution. But it represents really hundreds of individual services stacked on top of each other to build this complex environment that they have. And again, I use this diagram a lot. So the next diagram is also based on it, although a slight modification. So this is kind of a theoretical customer. Again, based on the same diagram, but this customer has a very similar connectivity scheme to site 1 and site 2. But in this environment, both the primary and the secondary cloud sites are active. It's not an active and a failover site. They have live servers in both. They do data replication across both, and they have a dedicated service. You'll notice that orange connection, that is a dedicated network replication service. They have site 3, which maybe is a smaller office that's using either VPN or, more recently, a lot of people have switched to SD-WAN, which is not necessarily technologically a lot different than VPN, but it offers largely in most of the SD-WAN products out there, it offers a lot of management capabilities, the ability to connect to multiple sites in a less complex manner. So on the back end, you still have all the VPNs, all of the private connectivity set up, all of the encryption, all of the routing. But on the front end, what you see to set it up is very much less complicated. You basically just have a pool of other sites that you have routing and connectivity to, and the system automates the back end portion of that so that you're not really configuring all of those individual portions. So it's actually made our life quite a bit easier from a large scale VPN deployment standpoint. The SD-WAN solution is just a lot easier to deploy at scale with lots and lots of connections. But as you can see, this design gives you a lot of options as far as how the connectivity goes. And each site has its own internet access from the standpoint of any type of publicly hosted content. You could have, your primary and your secondary cloud locations also through these firewalls hosting content to the internet, whether it be, the corporate website or, shared file storage, any type of application that, that you're providing for your customers. In the event of, maybe an insurance company, you might have the ability to fill out some of your insurance paperwork online, et cetera, hosted there with failover to the other site, and also storing directly on servers that have direct private connectivity to the offices with the agents or the call centers or whatever happens to be hosted there. So, fairly complex configuration, but can be made to look fairly simple with a good stacking of services that allows everybody to pretty much just come into work every day and connect to all of their resources and not really understand all of the underlying complexity that's being provided there. So there's a lot of new technology out there that can add to this and can make it really interesting. SD-WAN we just talked about, it's a very good example. It largely replaces VPN or what corporations traditionally used for VPN. It allows manageability to scale greatly, allows you to have a lot more sites, can make connectivity much more much easier for a company to put together and manage across all of their offices. And then lots of redundancy and policy routing. A lot of the SD-WAN options out there offer 2 or 3 or more connections. They can monitor those connections. They can route you from one to another, allowing you to choose what connection is best for any given application. Security appliances are a common addition to an environment like this. You have your basic firewalls, like we already spoke of, but you also have other layer 4 to layer 7 filtering options out there. There are some really excellent applications out there that do content management or what they call data or content control, where you don't want to let data outside of your network. The simplest is, several years ago for web filtering and web firewalls, it became very common to have a layer 7 device in place that prevents credit card numbers from escaping. So every time it saw a credit card number in a web page or any type of data or file that was being emailed out, it would pull the credit card number out, or it would just reject the file. So that's very common. There are others as well to look at all other types of content, whether it be email or file shares or web or application specific stuff. A lot of man-in-the-middle decryption, so that you can see, even if it's a private or an encrypted link, you can decrypt it and make sure that the data you don't want to escape the network doesn't have the ability to. Access control and policy enforcement kind of follows with that, as well as policy routing based on application performance. So, in a lot of cases, a firewall or an application device will understand the application and will understand what the needs of the application are, and therefore, if it has 2 or 3 different network connections to choose from, it can choose which connection is actually going to provide the best performance for, say, your phones at your office, or your web page, or maybe you're hosting your own DNS or your own email. In each of those applications, phone is very sensitive to jitter or changes in latency. It causes echo, etc., that you've heard on your IP phones, I'm sure, or your cell phones. Any type of change in latency can cause a lot of that jitter and echo. Web content isn't as latency or jitter sensitive, but it is very sensitive to packet loss. And then everything is sensitive to cost. You always want your content to go over the cheapest connection that can provide the performance that the application requires. So, a factor in a lot of the firewalls or dedicated route optimization boxes out there is the cost of a given link. And so they can say, okay, well, the algorithms inside the box will choose the best connection based on these given requirements that we have for the connection. So, hey, the jitter has to be less than this, the packet loss has to be less than this. If all things are equal, choose the cheapest link. And that allows companies to save quite a bit of money, particularly if you're looking at larger companies like somebody like a Google or a Facebook or something like that. Cost is a very big thing to them because of the sheer volume of traffic that they're doing. But even smaller applications that have a lot of visitors, that do a fair amount of traffic. I have worked with a lot of online training sites, and it doesn't seem like much, but if you're doing a lot of video training online, that's a lot of traffic. And for a small company that's just starting up, the difference between a $1 a megabit a second connection and a 75 cents per megabit per second connection can be an enormous delta when you're talking about hundreds or thousands or tens of thousands of gigs of traffic. And money. That is largely where I am at the moment. I think that that's about it. Does anybody have any questions, or is there anything anybody wants to talk about?
Hey, James. So we did have some questions in the chat. I just want to say you did an awesome job covering a lot.
Well, thank you.
Let me just go ahead and start with one of the first ones that I did see here. Why don't we go ahead and ask or start with Derry's question. With regards to DIA, are all the racks in the center connected directly via some sort of cable, Ethernet, or otherwise, or do data centers usually wireless, or do data center use wireless connectivity?
So usually in a data center, our wireless connectivity is for customers because, you know, we'll have customers come in to access their equipment directly. They'll bring in a laptop. Maybe they'll want a cable directly into their servers or their environment, but largely for accessing the internet or just using their laptop in the facility, we provide wireless. For most of the servers or the virtual environments, that's all cabled. You know, it's a good deal more reliable. And wireless has some real issues with speed, but also the sheer number of connections you can have. In a lot of our virtual environments, we have tens of thousands of servers, and most wireless access points only allow you 100 to 200 different devices to connect. And you're sharing, say, a gigabit of connectivity across those, 200 devices. So, there's some speed issues and there's some connectivity issues for that. At any given moment, though, usually in the data center, there's only 2 or 3 customers, and maybe, each of them has a laptop, but that's still only 2 or 3 laptops connected to wireless. So, we can get everybody on gigabit wireless to have a pretty good laptop connection, but from a server point of view, we pretty much use cables.
Awesome. I think that answered the question pretty well. So Derry did have another question, and it was referred to the diagram. Let's see which one. Let me just read the question for you. Or do you see the question there? On the first diagram, the replica said is now live, as I understood. How does the second replication happen? Second from the, and that's one question.
Okay, so yeah. From this standpoint, on this slide, the replication actually happens across this link. So the data it has a separate LAN that connects to the firewall, and the data just goes out from the primary site across this link to the secondary site. All the sites are connected together via this multi-point service. In the second diagram, there's a dedicated link here, this orange link for data replication, and this connects the switch on this side to the switch on that side. This is actually a much higher speed way of doing it because you're not relying on the capacity of the firewalls to limit how much throughput you can push from one site to the other. So in this case, we can do for our customers, and this is something a lot of the other cloud providers can do as well, we can offer 10 gig dedicated or 100 gig dedicated links from site to site to allow a tremendous amount of data replication if needed. Usually gigabit or a couple of gigabit is enough for most fairly large virtual environments, but sometimes people need a tremendous amount of data. Medical record storage is actually pretty common for massive data transfer needs.
Awesome. And Derry had another question to follow that. Second, from the network side of thing, can the replication hinder performance? If yes, what do you do to prevent that?
Particularly in the first slide where we have all the replication going through the firewalls do hinder performance. In the case of this particular environment that we built, the firewalls are capable of about 9 gigabit a second. In that environment, and the customer only had 1 gig to each of their offices and a couple hundred meg of internet, but the internet really wasn't important. They were doing mostly from the data center to their offices. So we really only had to worry about the firewalls doing about a gigabit at any given time of customer traffic. So we had 7 or 8 gig of replication from site to site. That was plenty for that particular need, but if you had more, you would go to this environment here where you had a dedicated replication link, as I mentioned. And again, at that point, you can replicate basically as fast as the hard drives would allow, or I mean, from a different standpoint, as fast as you could afford for the point-to-point link. Because the switches are not going to be your slowdown at that point. It's going to be either the hard drives or the point-to-point link that you're purchasing. And that, so either it's, you're going to run out on your left hand on the hard drives or on the right hand on the point-to-point. And if you wanted to go faster at that point, you have to basically spend more money.
Awesome. So yeah, so Derek said makes sense. So that was really helpful. But yeah, so it looks like we don't have any more questions in the chat. James, I wanted to add that my dad is actually here with me today, and he works for Cato Networks, and he was really impressed and would like to connect with you on LinkedIn and see how he could work with you.
Yeah,
but
fair enough.
He did a good job, because I understood only a little bit, but that means you did amazing. So
well, I tried to keep it not too deep, but I think it covers some good topics. So hopefully everybody enjoyed it and found it somewhat interesting.
Yeah, no, you did very well. And we will be sending this recording to all the attendees. James, awesome. You can share it out with your network as well. And yeah, that looks like a good way to end the night.
Cool. Well, I hope everybody had fun, and it was wonderful being here, and I look forward to contacts from anybody, and if anybody needs anything from me, I'm always available and happy to help in any way that I can. Our whole team is. So I've been floating around Central and South Florida IT for 20 years now. So again, happy to help in any way I can.
Awesome. Thanks, James. And we'll see you in South Florida, hopefully very, very soon this year. You can host another event for us. And we're so glad you guys are our new members this year. So
awesome.
Thanks, everybody. We'll have a great night, and we'll see you guys next week.
Definitely. Have a good night, everyone.